In this lecture, we are going to illustrate the use of the moment distribution method for analyzing frame structures with no side sway. The analysis here is very similar to the case of continuous beams. First, we calculate the distribution factors and fixed end moments. Then we set up the moment distribution table and go through the process of balancing the joints and determining the carryover moments repeatedly until a desired accuracy is reached. For our frame structure, we already know the distribution factors at the supports. If you are not sure how these values are obtained, please review Lecture SA 39. For the interior joints, we calculate the distribution factors this way. Noting that the moment of inertia for the columns is twice the moment of inertia for the beam, we write the stiffness coefficients as 2EI over 4 for the columns and EI over 6 for the beam. This makes joint stiffness at B 2EI over 3. Hence, the distribution factors at the joint are As for joint C, its total stiffness is also 2EI over 3. This makes the distribution factors 3 over 4 at the column end and 1 over 4 at the beam end. Now, let's calculate the fixed end moments. Member BC is subjected to a concentrated load at its midpoint. This results in a fixed end moment of 6 kilonewton meters at either end of the member. To draw the distribution table for the frame, flatten it like this. And place the distribution factors in this manner. Then write the fixed end moments. The table is now set up, ready for the iterative moment distribution process. We start by balancing the joints. Initially, only joints B and C need to be balanced. We then carry over half of the balancing moments to the other side of each member, like this. We balance the joints again and add the carryover moments to the table. Let's balance the joints one more time. Note that past this point, any additional iterations would not significantly alter the moment values. Therefore, we mark this as the end of the iterative process. We can now determine the member end moments by adding up the values in each column. Finally, we apply the equilibrium equations to each member in order to determine the remaining unknown forces. Here are the support reactions for the frame. Let us examine another case. Here we have a joint that connects 3 members. This leads to an important question. How do we set up the moment distribution table when such a joint is present in the structure? Let's start by determining the distribution factors. At the fixed supports, we have, for joint B, we can write and for joint D, we get The fixed end moments for member BD are to set up the moment distribution table, we imagine a flattened frame, like this. However, as you can see, the frame cannot be flattened completely, which means we cannot set up a table with contiguous columns. Since the table needs to have a column for each member end, we need to create a separate pair of columns for joint C, like this. Then, the distribution factors are placed like this. To add clarity to the table, let's label its columns. I am going to label this column AB. This means the column contains bending moment values for the lower end of member AB. And this column I label BA. It is for bending moment values at the upper end of member AB. We label the remaining table columns in a similar manner. Note that for CD, bending moments at the lower end of the member need to be written here, and the values for the upper end of the member go here. This is important to keep in mind since half of any value that is added to this column needs to be carried over to this column. Here are the fixed end moment values. Now we can begin the moment distribution process. Let's start by balancing joint D. We need a moment of 6 kilonewton meters to balance the joint. This value needs to be distributed among the 3 members according to the distribution factors, like this. We then balance joint B. Since all the joints are balanced, we determine the carryover moments and add them to the table, like this. Note that for joint D, we carried half of this balancing moment to this column. We balance the joints again, then add the carryover moments to the table. We continue this process until the moment values become negligible. Once we reach the end of the process, we add up the values in each column to get the member end moments. We can then calculate the member end shear forces and support reactions. Here are the results.